Here we're going to solve when there's more than one radical. So remember, to get rid of a square root, I can square both sides. But notice if I do that right now, I have two terms I'd have to FOIL with these square roots. So for squaring to be productive, I need a square root by itself. So I'm going to get this square root by itself by adding this one to both sides, so that this one ends up over on the right. All right, so now at least when I square both sides, all of both sides, and notice here, if I square something that has two terms, I'm going to have to FOIL. So what I usually like to do is think, well, squared means something times itself. So just literally write something times itself instead of the squared. That way when I FOIL, I can see all the parts of my FOIL. So squared and square root cancel, just 7x plus 46. And then here, 3 times 3 is 9. And my inside term is 3 times the square root. My outside term is 3 times the same square root, so that's 6, if we get like terms together, copies of the same square root. And then last here, x plus 31, because if I do square root of something times itself, square root of something squared, the square roots cancel. All right, so now we can get some like terms together, like this and this, maybe subtract x from both sides. So I have 6x plus 46 equals 40. Plus 6 square root of x plus 31. So notice I want to get rid of this square root here, which means I also have to get it by itself. So I'm going to move everything I can to the other side of the equation. So like minus 40 minus 40. So 6x plus 6 equals 6 square root of x plus 31. All right, so notice this 6 is multiplied by x plus square root of 31. So I can divide both sides by 6. Let's make ourselves some room. So if I divide both sides by 6, I end up with x plus 1, right, the 6's, and the other side the 6's cancel, and square root of x plus 31. Now that square root's by itself, so I can square both sides. So here the square and the square root cancel, so I'm just left with x plus 31. But here I have to FOIL x plus 1 times itself, which is first outside inside is 1x, add together. And so now I notice I have something quadratic, and so I have to get it equal to 0. So I'll subtract x from both sides and subtract 31. So x squared plus 2x minus x would be plus x. And then 1 minus 31 is negative 30. And so now that it's set equal to 0, if I can factor it, that should give me a solution or possible solutions to this. So x plus 6, x minus 5 multiplies to negative 30, adds to 1. So two solution possibilities are 5 and negative 6 if I set those both equal to 0. Now something important about these answers, you have to check them. Errorless checking is generally important all the time, but in these equations you can actually do everything right and get answers that don't work. They're called extraneous, which is a fancy word for extra solutions. It comes from those times when we squared both sides. If you square a negative number, it could end up positive, so two things that aren't actually equal could look equal. So I'll take my original equation, seems like a long time ago since we had this. So take the original equation and we'll try 5. So if I put 5 in here, this will be 7 times 5. So square root of 35 plus 46, or square root of 81. And then here, this will be square root of 36, 5 plus 31. And over here, this is 3. So square root of 81 is 9. So 9 minus 6 equals 3. 3 equals 3. So it looks like this answer works. And now we'll try the other one. So if I do negative 6, here I get 7 times negative 6, so negative 42 plus 46, which is square root of 4. And then negative 6 and 31 gives me 25. And so square root of 25 is 5. and square root of 4 is 2, so 2 minus 5. See how 2 minus 5 equals negative 3 and not 3? So that tells me that solution doesn't work. So I only have one solution to this. It's x equals 5. So you have to check them. There's not exactly a very easily discernible pattern. Sometimes they both work, sometimes neither of them work, sometimes only one of them works. The only way to tell what possible answers are going to work is to check them.